Hello, and welcome to SEC 323 reInvent. My name is Freddy. I'm a security consultant with AWS, assisting customers build instant response capabilities and responding to security events. I thought sharing my experience could be beneficial, and that is why I put this talk together. I see customers facing similar challenges, such as alert fatigue, inadequate playbooks, and lack of log analytical capabilities. So some of the common root causes I have observed are, number one, incident response capability development is detached from the main effort that builds and maintains security controls. Number two, incident response building is left for later and usually the last thing that gets done. Number three, alerts are selected on generic assumptions, not tied to the workloads in the cloud. And last but not least, number four, lack of applied AWS cloud security fundamentals in incident response. So on that note, the agenda for this talk starts by looking at the fundamentals of AWS cloud security. Because as a builder, you need to master the fundamentals. They'll help you establish the right mindset to build your IR program. I can tell you, that's the secret sauce of professional services security practice I'm part of. So next, we'll look at an incident response maturity model. And finally, I'll go through the foundations of incident response, which are educate, prepare, simulate, and iterate with a demo. So what better place to start than the shared responsibility model? From an incident response perspective, think about the amount of components in a workload. So let me give an example. Imagine a three-tier application with a database component. You have the option of deploying an EC2 instance, installing and configuring the operating system, and the SQL product of your choice. Now compare that with Amazon RDS, our relational database service, powered by the same SQL engine you picked for your EC2 instance. RDS runs that SQL engine in a compute node in some availability zone, and that compute node is in AWS's side of the shared responsibility. You won't need and you won't have access to the operating system in that compute node. In the case of the database engine running your EC2 instance, both the operating system and the SQL engine will be on your side of the shared responsibility. So another fundamental piece of cloud knowledge can be found in the security pillar of the AWS well-architected framework, focusing on recommendations and strategies to use when designing cloud architectures with security in mind. What does it talk about incident response? Well, that even with extremely mature preventative and detective controls, your organization should still implement incident response. So continue with the fundamentals. The AWS Cloud Adoption Framework, the CAF, helps organizations develop and execute efficient and effective plans for their cloud adoption journey. The security perspective of the CAF makes a big call out that the security controls are interrelated and interdependent. So let me explain how that works. Directive and preventative controls establish a baseline so you can use detective and responsive controls to alert and investigate any deviations for such baseline. So by adopting this approach, you'll have a lower false positive rate and enhance your overall security posture. Last but not least, we have published a white paper that consolidates our experience with incident response and all the security fundamentals I have just mentioned. All in all, the security controls are better when built together. So the number one question I get asked is what alerts should I care about? Well, that comes from your workload threat modeling, because incident response is really about what you're trying to protect. When you threat model your workloads, the activity baseline is discovered so you can nail what exceptional events you want to alert on. Make sure statutory and regulatory compliance requirements are part of the threat modeling, as those might mandate specific alerting that the pure threat modeling would not catch. So here's a simple example of a fragment of a threat model of a workload that uses the simple storage service, S3, as one of its components. There are other components as part of this workload. You have established the baseline that the S3 buckets related to this workload can only be deleted by certain IAM principles as part of a pipeline process. Now you can determine detective and responsive controls to alert and deal with deviations of this discovered baseline. You're narrowing down the use cases to be dealt with by the incident response team instead of alerting for every S3 bucket that has been deleted. Now let's talk about noise. I run this experiment to help demonstrate what happens when alert selection is not tied into threat modeling of the workloads. I deployed one EC2 instance with one exposed service port to the internet running a web server. In about a minute and a half, I started to get bombarded with scans. Now multiply this by hundreds or thousands. Can you imagine how many alerts will be generated for you to look at in your security tools that are not relevant? Well, the end result of this is what is called alert fatigue. Your responders are so used to getting alerts for everything and anything that when the real one comes, they're already numb and will be ignored. So let's check out that maturity model. Well, before we do that, let's look at the internals of a security event. So did you know that actors and incident responders, they have a meeting place? Yes, that place is called the logs. As the actor performs actions against a single or a set of accounts, those get captured by the service infrastructure and application logs, such as CloudTrail, VPC Flow, Elastic Load Balancer logs, Web Application Firewall logs, to name a few. It is important to note that the actor's activity will blend with the normal activity of your set of accounts. And that's exactly what your threat modeling is helping with. With that said, logs are a fundamental piece of your IR program, and we'll take a look later in this talk on how those are selected. Now, a very important distinction is needed regarding the actor's real intent, which does not get directly captured by the logs. We can infer by looking at the logs if the actor is working in a targeted or opportunistic manner. Why is this important? Well, that's where automation will help you the most. You want automation to make containment and eradication decisions as much as possible for opportunistic behavior, such as port scans, brute force, vulnerability scanning, etc. You just remediate and move on. In the case of targeted behavior, which means the actor is vested to get what they want from you, you need people dedicated and focused, simply because automation cannot help make cognitive decisions. At least that's the current limitation of artificial intelligence and machine learning. You want your responders' undivided attention throughout the life cycle of an event that you have detected. But you also want to look for additional indicators through threat hunting. So the maturity model has 3 levels. The higher the number, the more mature it is. So let's take a look at those 3. So maturity level 1, 0 playbook. Notification comes in, someone in the enterprise receives it and figures out that something is wrong. There is no trained staff to respond or procedures to follow, so the alternative is usually calling someone. Maturity level 2, the classic playbook. So notification comes in, it hits the responder directly. In this case, the notification came from an alert generated by a security tool. This alert was generated based on findings, and those in turn were generated from parsing, normalizing, and correlation of the logs we talked about. So these steps here together represent the threat detection phase. So going back to our responder, she looks at the notification, has to figure out what logs are relevant to pull for triage, scope, and impact, manually goes out, accesses analytical tools such as a SIM, pulls the playbook. The playbook doesn't really help. This alert is using a finding that's not documented. She now has to go to the console of the service that generated the finding, search for it, interpret what it means, figure out what other log sources need to be queried. Well, you got the gist. So after all that, she'll continue with additional actions, running forensics, contacting stakeholders, initiating automation for containment eradication, and finally the whole picture of the incident is put together to be analyzed and provide recommendations to enhance detective, preventative, responsive, and directive controls. In maturity level 3, Playbook as code, it leverages cloud-native concepts such as infrastructure as code and event-driven architecture. So let's run this scenario. In the threat detection phase, we have alerts selected based on threat modeling, taking into consideration the workload baselines, resulting in lower false positive rate and noise. Automation runs prior to the responding entering the scene, facilitating with triage, containment, and eradication. Incident data is aggregated as part of the automation process for the responder to analyze, and she does not receive a notification for every single alert. She gets involved in selected alerts. Again, based on workload threat modeling and the current threat climate. If the alert requires responder action, she'll be summoned. We'll have a copy of the playbook already pulled from the IR Git repository. We'll start involving additional stakeholders. We'll continue running human-initiated automation as needed to complete the data set for the event and other containment and remediation actions. At this point, triage, scope, and impact have been completed, and most other actions as well. And all the data has been stored for post-incident review. So an important note on alerting and notification is that in exceptional cases, you will receive a notification that does not come from a security tool or guardrail. It does not invalidate this model. You still can modify the existing automation that assists with triage and the initial containment to be human-initiated and not event-driven. So the main message here is to be prepared to respond to incidents that the alert will come from a third party or an internal notification like email or instant message. So let's recap what's getting in the way of a good response and improvements. Firstly, too many alerts or no alerts. We talked about threat modeling and interdependency of the security controls. So this one, we know what to do. So next, in this day and age, it is hard to find people with security skills. The responder is a specialization of a specialization. You want to enable them to be as efficient as possible and focus on cognitive tasks, such as alert analysis and decision making. The fundamentals of the cloud, again, are very important. to prepare your responders, and we look at the CAF, well-architected, share responsibility, and the IR white paper. So go deep on those. And how about automation? Well, it has not been used to the degree it could. And one of the reasons, understandably, is due to fear of blocking legitimate activity. But, history repeats itself, right? Remember when we were afraid of patching systems because they would break? We realized there's a much higher risk of not patching. In the same token, I believe if we carefully plan and agree upon with workload owners the impact of blocking legitimate activity in the side of caution is feasible if systems are designed for failure. That is a pattern that can also be found in the AWS well-architected framework. So even when legitimate activity is impaired, it can be recovered with minimal impact. I know it might not apply to every situation or use case, but it's a concept that should be considered. And that is not all for automation. There is an opportunity assisting the responder in the triage phase by pulling, enriching, and correlating the instant data. So when the responders are involved, they'll dive straight into the analysis and not the clerical stuff. Last but not least, playbooks are supposed to facilitate the foundation of instant response, which is educate, prepare, simulate, and iterate. You don't want to craft playbooks to be in a network share somewhere or printed just to comply with an internal policy. Take advantage of the playbook as code and treat them as everything else you do in the cloud. Well, this is not all talk. It is real. So let's take a look at a Sprint 1 demo of the playbooks as code. In the playbook as code maturity level, the IR Git repo contains documentation and code. I'm going to run here a bash script containing a few CLI commands that simulate an actor using the root user for an AWS account. As you know, the root user should not be used regularly, and your team has to be prepared to respond when it's used outside the threat model's baseline. In the background, you see code commit hosting the IR repository and a mailbox to receive the notifications that's empty now. A guard duty finding is expected to be generated that in turn will create an alert and associated notifications. Now that you see the notification came in for the alert that the root user activity was detected. So going back to the guard duty console, we'll see the finding there. We can open it and check the related observables such as IP address, API call made, timestamps, and the description at the very end. So going back to the notification, we see some of the guard duty finding observables in human-friendly format, as well as a link to the Git repository. So as part of the triage, the alert automation that pulled some of the data related to the event. In this case here, 2 Athena queries were submitted on behalf of the responder. One for the guard duty finding details, which we see here, and another for the CloudTrail logs related to the root user activity. These are just results of the query submissions. The query have already been run by the automation, and the investigator is just pulling the results stalled by Athena in an S3 bucket. The fields selected for the queries, they are fully customizable and pulled from the guard duty and CloudTrail logs. So as you can see here, there's event name, source IP address, user agent, and other details about the activity generated by that particular script. that's simulating root user. So going back to the alerts notification, let's take a closer look at the IR Git repo contents supporting the fundamentals of instant response, such as educate, prepare, simulate, and iterate. Inside the root user playbook section, we find a bash script that was run to simulate the alert, as you see here. The playbooks are used for educational purposes as well. The root user activity playbook has details about the threat, what is the goal of the response, and the steps to investigate. So a seasoned responder would go through the steps outlined here, but new staff will find additional details with Athena queries, CLI commands, and expected outputs illustrated as she continues to scroll through the playbook. There are other relevant information that's kept in the Git repo, like you see here, that would assist responders with their responsibilities in general, and not just playbooks for specific use cases. Fantastic. So let's recap and put more detail into certain aspects that we've talked about. So as you saw in the demo, the Git repo facilitates education of responders, preparation for security events, contains simulation procedures and scripts, and facilitates continuous improvement as responders iterate through incidents and evolve the organization's IR capabilities. As it is in a Git repo, a process can be developed to support branching and merging of content. So let's run through an end-to-end example that will build all you need to respond to any specific alert. So how do I get from workloads to alerts? First, pick one workload and break it down into service dependencies. Here we see EC2, IAM, and S3. This is just an example. It is important to understand how they are configured and will be used, so the threats can be identified and the baseline discovered. As you see here, the threat list is generated and related alerts are defined. The relationship between threats and alerts is not necessarily one-to-one, it could be many-to-one. So continue our exercise. Let's pick one alert. Unauthorized access to EC2 instance detected, the one highlighted in the screen. Then we ask the question of what findings could support this alert. Here we can see 4 distinct guard duty findings that will provide us with enough observables for an investigation. The example here is with guard duty, but regardless of the security tool used, as I mentioned prior, findings are generated based on parsing, normalization, and correlation of logs. These specific guard duty events are generated based on DNS and VPC flow logs. So you need these logs available for the investigation. If you're using guard duty, don't forget to configure the export of the findings to CloudWatch or S3 for future reference. And if you're a fan of Security Hub like I am, aggregate there as well. Now that the log sources have been defined, you need to determine their storage location. And it's based mainly on your retention requirements and analytical tools of your choice. Those are just the 2 main things. There are more requirements. Here we are using S3 and Glacier to store the logs, and Athena and Detective for investigations. Athena will require the logs to be in the S3 buckets for the queries to be run. Detective, on the other hand, will use its own database of your logs to assist with the investigation. The decision analytical tools boils down to your specific needs. So consider learning more about not only Detect and Athena, but also Elasticsearch, CloudWatch Insights, EMR, and in other reInvent sessions, so you can make an educated decision. This is the diagram of the solution that I showed in the demo. Sprint 1 is what is already implemented, and Sprint 2, the purple, is the next evolution step. Agile is definitely the way to go to get your IR program off the ground and make incremental changes moving towards your goal of the playbook as code. Sprint 2 is adding containment procedures based on the logs pulled from the triage we saw in the demo. The new Lambda function will perform actions based upon the activity detected. The goal is not to automate everything, but to automate everything that can free up time from the investigators to spend in cognitive tasks and as little as possible with clerical stuff. So in closing, we can gradually enhance your incident response capabilities by adopting cloud-native concepts. So consider using a Git repository for everything incident response. Expand the scope of automation to include triage, pulling the relevant logs in advance before the responder is called into actions. It takes too long to run queries sometimes, and actually find the queries that you want to run. So blend your Git repository with code and documentation, like I showed in the demo. So everything is going to be in one place. And make the playbooks an opportunity for responders to learn by having these pre-baked scenarios and analytical tool query examples with their results. And if possible, leverage your existing CI/CD pipeline for instant response. So with that, thank you very much for listening. Talk to you next.